Hi everyone, let's start solving today's LeetCode daily challenge question, which is 1319, number of operation to make network connected. This is a very simple and straightforward question. Okay, let's try to understand the question first. So there are n minus 1 computers given to us which are connected by some Ethernet cables. What we need to do in this question, we need to return the minimum number of times you need to do this in order to make all the computers connected. So we need to connect all the computers by Ethernet cables. What operations can we perform here? So we can extract any Ethernet cable from any computer and connect with some another computer. Okay, so as you can see this example, so this is a extra Ethernet cable. If I extract from this computer 1 to 2 and make the connection from 1 to 3, so in one operation I can do it. Okay, so this why this question is very simple and straightforward, because we need to write all the observation first, and this question is going on all the observation what we are going to write in this question. Okay, so let's see one by one. So the first observation, very unique. If you solve any graph question previously, you must be seeing all the nodes will be starting from 1 to n, but in this question it is starting from 0 to n minus 1. Okay, this is the first observation. Okay, what is the second observation? From this we can observe this: if there are n nodes, can we consider all the computers as nodes? So if there are n nodes, how many edges, how many Ethernet cables we require to connect all the computers? So as you can see here, if there are 4 computers, the minimum requirement of Ethernet cables are n minus 1. If there are n minus 1 Ethernet cables, or you can say edges, we can make the network fully connected. So minimum number of edges required. So minimum number of edges required are n minus 1. N minus 1. This is a very important point. We need it as per solving this question. Okay. So the main thing now remains is to find out the number of edges. Okay. If we see the example clearly, the number of edges given to us in the input only. So number of edges is nothing but the input array length. Okay, now what we need to calculate in this question? So what we need to calculate in this question? The numbers of not connected computers. This example will not clarify a lot of things for you, so let me take another example. Okay, so what the example I am taking, let me show you. So let's say 1 is connected with 2. It is an undirected graph. Okay, 2. 1 is connected with 3. Okay, let's say 0, because as per question we need to go with 0 to n minus 1 notation. 0, 1, 2. Okay, and there is 0 is connected with 3. Now there is a 4 and there is a 5. 4 and 5 are connected, but it is not a complete connection. Okay, and how many number of edges? Let takes one edge from 1 to 3 as well. So if you solved a previous question of number of islands on graph, so this question will be very easy for you now after I written all the observation, because in this question what we need to calculate now, the number of not connected graphs. Okay, which are not a part of connection. The if it is not a fully complete graph. Okay, so as I am seeing, this is a connected component and this is also a connected component, but these is not a fully complete graph, because there is no connection between between this connected graph and this connected graph. So we need one more Ethernet cable to make this connection established. Okay, do we have enough edges? So let me calculate first. So there is one edge, 2 edge, 3 edge, 4 and 5. Okay, 1, 2, 3, 4 and 5, and n is equal to 6. How many nodes are there? 0, 1, 2, 3, 4 and 5. As per observation, if there are n nodes, I required n minus 1 edges to make the connection complete. Okay, so how many edges I can take? I can take this edge and connect with this, or either this. Okay, so in this question, now this graph is completed. This is a complete graph now. Complete graph now. So I know this observation. If there, I know the total number of nodes, I know the total number of edges given to me. What I need to know now, is there any node connected? Is there any like a node connected component in the graph present or not? Let's suppose if this is the given example, 0, 1, 2, 3, 4 and 5. Let me collect all the edges, 1, 2, 3, 4 and 5. There are 6 edges, there are 6 nodes, n is equal to 6, and there are 5 edges. So I can connect all the nodes with their particular edges. But in this question, do I need any edge, any extra edge to connect? Any movement I need to do? No, because the whole network is already connected. So in this question, the main problem is to find the no node connected graphs. Okay, so if there are different graphs given to me, 0, 1, 2, and there is 3, 4 and 5, and there is extra edge present, so I can say yes, it is possible. And how, what is the number? That is simply the node network component. So in this there is only one node network component, so the answer will be only one. Okay, so if I need to find out the node network component only, that I can simply achieve with the help of DFS and BFS as well. So with the both, so I can choose either BFS traversal, either DFS traversal. With both I can solve this question. So let me give you a code walkthrough of this problem statement. I have done this question using both the traversal DFS as well as BFS. Okay, let me give you a code walkthrough. So this is the first. Okay, I created a global adjacency list and a visited array. I created the adjacency list. Okay, so if you don't know how to create an adjacency list, you first need to get an idea how to create an adjacency list. Adjacency list is nothing but a technique to store all the information how an node is connected with different nodes. Okay, so I created a node visited. What is this variable? This variable will simply give me the information of node connected graph components. Okay, so I can, for all the nodes I will either call DFS or either call BFS. Okay, and why I'm doing node visited minus minus? Because the one network I can easily access, which is the 0, which is our starting point, so I do not have to consider that as a no node connected component, because that is always connected, because that is my starting point. Okay, so if I do a DFS call, so that DFS is always a recursion call, so this is the code of the DFS. Okay, so I am iterating all the nodes of the connected, I am traversing all the edges of the connected nodes in the DFS. Okay, the same I am doing in the BFS. So in BFS I need to use a queue. Okay, so while queue is not empty and I am marking all the uh, nodes which I visited already as true, and if it is not visited, I am iterating those nodes. Okay, So this is available edges. What is available edges? Which are shown you in the observation, which is nothing but connections dot length. If not visited is equal to 0, there is not a single not connected graph component present, I will simply return 0. Else, if available edges is greater than equal to n minus 1, where did we get this information? From the observation only. So I will return the not visited, the not visited component of a graph. So if there are not connected graph, I will return simply that. Or if available edges is less than n minus 1, can I ever be connect all the nodes? No, it is not possible. So in that case, I will be simply returning -1. So that's it from this question. I think if you find this video helpful, so please like this video and subscribe to my channel. Thank you.